Hi students, welcome to my YouTube channel. In this video, we will learn about nuclear reactions. Before going to start, please subscribe my channel and press the bell icon for notifications. So let us start today's class. So what is nuclear reaction? When the projectile is projected at the target nucleus, if there is a change in atomic number or mass number or atomic mass in target nucleus, then the nuclear reaction is said to be taken place or is called nuclear reaction. So you can see here projectile hit to the target nucleus. If there is a change in its mass number or atomic number, then we can say that nuclear reaction has taken place. So we can define nuclear reaction as when projectile hit to the target nucleus, change in mass number or atomic number indicates that nuclear reaction has taken place. So what are the features of nuclear reactions? When projectile is projected at target nucleus, then there may be scattering of projectile may takes place. Okay, as we know, when two particles interact, scattering may takes place. So scattering is two type, elastic or inelastic. So this is the first condition. And second one more particle which are in entirely different form particle is emitted. In the first case it may be a scattering, or in the second case one more particle of entirely different form may be emitted after the interaction. Third one, projectile may be captured and some gamma rays may be emitted. So another condition is that projectile when hit to the target nucleus, it is completely captured or absorbed by the target nucleus and some gamma rays can be emitted. So these are the few features of nuclear reaction. So the first nuclear reaction that was held in 1919 by Rutherford. That's why we have the alpha Rutherford scattering. So this is the reaction, how we can define it. When alpha particles interact with nitrogen target nucleus, then alpha is going to be absorbed by this nitrogen, and you can see there is a change in its mass number as well as atomic number, and the proton is going to be emitted. That's why the equation must be balanced. So this is the outgoing particle. So we can represent nuclear reaction in this way also. We have to keep the incident and outgoing particle inside the bracket and target, and the target nucleus before and after reaction we can write outside the bracket. This is the other way to represent nuclear reactions. So what are the types of nuclear reactions? So we can see here there are three types. First one, scattering reaction. So when the projectile hit to the target nucleus or the incident particle hit to the target nucleus, if there is a change in its direction, then we can say that scattering has taken place. It may be elastic scattering or inelastic scattering. So we can understand it by example. We can see here in this example elastic scattering, when the helium, that is incident or projectile, hits to the target nucleus of gold, then we have the similar kind of outgoing particle, that is helium itself, and there is no change in the nucleus of target material. So we can say that incident and outgoing particles are same in this reaction, and target nucleus is in the ground state itself. So this is the elastic scattering. Inelastic scattering, here the incident particle and the outgoing particles must be different, and target nucleus must be in the excited state. So we can see here, this is the incident particle, hydrogen, this is the lithium. If this is in the excited state, then the outgoing particle, that must be different. This is called inelastic scattering. So the second kind of reaction is direct reaction. There are two types, pickup reaction and stripping reaction. So pickup reaction, as the name indicates, when the incident particle hit to the target nucleus, it will pick up some of the nucleons from the target nucleus. Then the outgoing particle must be different one. So this is the reaction this is the example for this reaction. So here incident particles pick up some nucleons. The second kind is stripping reaction. So in this reaction, so nucleus of a target material is going to absorb the nucleons from the incident particle. Okay, the outgoing particle is different one, and the target, we can see there is a change in mass number and atomic number of the target nucleus. So here in this case, nucleus absorbs the nucleons. So the third type of reaction is compound nuclear reaction. This reaction takes place in two steps. In the first step, formation of compound nucleus will takes place. In the second step, the decay of compound nucleus will takes place. In the first step, when the target nucleus is interact with the incident particle, then it is in the excited state by absorbing the incident particles, or that is going to change the disturb the nucleons present in the target nucleus. In the second stage, when it is in the excited state, due to the disturbance of nucleons, it is going to decay. Decay of compound nucleus will take place by emitting the particles. You can see here, they may be in different ways. So these are the outgoing particles. So this is about compound nuclear reaction. So what is the difference between direct and compound nuclear reaction? So direct reaction is single stage reaction, whereas compound nuclear reaction is two-stage reaction. So the second difference is, in direct reaction, projectile pick up or leave the nucleus. In case of compound reaction, doesn't disturb the target nucleus. That means nucleons are not going to be disturbed in the direct reaction, and compound reaction, they are going to be disturbed. Okay. So the third difference is direct reaction is quick reaction, that is of the order of 10 to the power minus 26 second, whereas compound reaction is slow, that is of the order of 10 to the power minus 16 second. So this is all about the types of nuclear reaction and the difference between the direct reaction and compound reaction. I hope this video is useful for you. If this video is helpful, then please like, share and subscribe my channel. Thank you for watching.